page 391, and this is going to be number 35. Okay, you've got two equations. So you have y equals x plus 1, that's one of them. And the other one is y equals 1 divided by x plus 1. So you're trying to find the area of the region bounded by these two curves. So you need to know which one's the top and which one's the bottom. So we're going to go ahead and graph these two. So there's our x and y axis. So the first one, y equals x plus 1, crosses the y-axis a positive 1, slope of 1. So that's your y equals x plus 1. There we go. The other one, it's got an asymptote at negative 1. So it kind of scoops like this, and then, okay, I drew it poorly. It never crosses that x-axis, but it does get really, really close to it. It does the same thing on the other side, but we're not necessarily interested in what goes on over there because they gave us our boundaries from 0 to 1 on the x-axis. So we're interested in from 0 to 1 on the x-axis. So this is the region we're talking about right here. Okay, that's the region that's between those two curves. You can see from the picture that the blue curve is on top, green curve is on bottom. And so, to get the area between them, it's the top curve, which is x plus 1, minus the bottom curve, which is 1 over x plus 1. And all those are in terms of derivatives, so we have to integrate or do antiderivative. So, for the first term, x, when I integrate that, I get x squared divided by 2. Remember, you add 1 to your exponent, and then divide by your new exponent. With positive 1, that becomes x to the first. And this one over here, when you have something in the denominator and the derivative of it is sitting in the numerator, that's natural log. So you have the natural log of x plus 1. Remember, the derivative of natural log is 1 over whatever you have times the derivative of what's inside. Well, if you notice, that's what we have here. We have 1 over x plus 1. Derivative of what's inside is 1. Okay, so when I do antiderivative, by the way, you have to divide by the derivative of what's inside, but that's 1, so I don't have to show that. Okay, so I'm done with my integration here. I'm going from 1 to 0. So when I plug in 1, I get 1/2 plus 1 minus the natural log of 1 plus 1, which is 2. And you're going to subtract what you get when you plug in 0. So I get 0 plus 0. And then minus natural log 0 plus 1 is 1. Okay, so that's what I have. Natural log of 1 is one of those things. I'm going to kind of talk about it over here to the side. That's one of those things you should automatically know. You shouldn't need a calculator for that. When it comes to natural log, you should know right off the bat what the natural log of 1 is and what the natural log of e is. And you're going to see those frequently in calculus 1 and 2. But if you remember, natural log is a logarithm of base e, and a log is an exponent. So this right here is saying what's the exponent that goes with e that will give you 1 for an answer. So the answer is 0. 0 for an exponent is how you end up with 1 for an answer. So the natural log of 1 is 0. Coincidentally, natural log of e, base e. Again, you're looking for the exponent for e that will give you e to the first, so the exponent's 1. So I ended up here with all zeros. Once I plug in the natural log of 1 is actually 0. All that is zeros. So I end up with 1/2 plus 1, which is actually 3/2, minus natural log of 2. That's a good proper answer right there. You don't need to get a decimal approximation for the natural log of 2. So that's your answer there. That's number 35. I'm going to go ahead and do, on this same little video, number 39. So if you want to pause the video, maybe you want to try 39 first and then come back and try this one. If you get stuck on 39, maybe you want to come back, maybe you don't. I don't know. But 39 I do want to do only because the integrating is kind of funky there. So you have y equals x times e to the negative x squared. That's your curve. They also gave you the curve y equals 0. Now that's the x-axis. And the line we call everything curves, by the way, even when they're lines. So technically, and the curve, x equals 1. So we're going to graph this so we have an idea of what it looks like. The graph of this, if you're using your graphing calculator, by the way, you're going to have to adjust your window. Most of your windows are defaulted to going from negative 10 to 10 on the x-line, showing every point, whole number point, and negative 10 to 10 on the y-line. Well, if you do that and try to graph this graph, you're not going to be able to see what's going on. So you have to zoom your window on the y-axis. So if you zoom it to go maybe from negative 1 to positive 1 and use 0.1 for your scale, then you can see that what you actually have is this weird little funky, it curves like that and it curves like that. Okay, that's what you get, weird little funky thing. The y equals 0 line is there, the x equals 1 line is like here, and you're looking for the region bounded, and you're talking about that region right there. So, for my integration, again, I'm going from 0 over here to x equals 1, so I got 0 to 1. It's the green curve minus the blue curve, so it's just x e to the negative x squared minus 0, which I don't have to show. Okay, and this is given to us in terms of a derivative or a curve, and we want area. So that's antiderivative. The reason I wanted to do this is because you kind of have to do something that maybe you don't have experience with, or maybe you do, but this is a U substitution case. So when I look at this, it looks like a product, but there is no integration of a product. There's no like anti-product rule. You can't just do the derivative of the first one and say, oh, that's that, and then do the derivative of the second and multiply. You cannot do that. Okay? So you kind of got to look at other methods here. So it looks like, oh, I can't do it. But if you look at that exponent, you have negative x squared. The derivative of that would be negative 2x. Well, you have an x to the first sitting next to it. So when you notice that, what you want to do is what's called a U substitution. So if you have what looks like a product and it's kind of messy, especially when you have e, let's look at that exponent of e. Let's make it simpler, and let's just call it u. Let's get it down to just one variable here. I mean, something simpler. All right, u equals negative x squared. Then when you're doing u substitution, you always then say, well, what? Oh, I hope that line doesn't show up on yours. What's the derivative of u? Because what you're going to have to do now, when you say I'm going to u substitution, everything that's got an x in it has to be replaced with a u. So instead of dx, I'm going to have it du. So that's why I'm finding the derivative of u. The derivative of this would be negative 2x dx. So that's what I have. So I have an x dx. So I need to get rid of that negative 2 over here. So I'm going to divide both sides by negative 2. So I have negative 1/2 du is equal to x dx. So now I have everything over here in my integrand that was an x, I can replace it with a u. So that x dx, that x dx, I have down here what it equals. It equals negative 1/2. Now I'm going to put the du at the end because we always put the d at the end. And then instead of e to that funky exponent, I have e to the u. Okay, so we got all that stuff going on. Let's keep going. When you're doing antiderivatives or integration, if you have a coefficient, they just kind of cloud things up. They make your integrand messy. They just go along for the ride when it comes to derivatives or antiderivatives. So you can always move a coefficient out. Again, only if you're multiplying by a number. You can't move a variable out. Couldn't move it if it was addition. But this is all multiplication. So when I move it out, it makes it a little simpler. So now just do your derivatives, your integration as if that, was an x, a regular variable. So remember, e is its own derivative. So that means you started with e to the u. When you are doing antiderivative, you always divide by the derivative of the exponent. The derivative of u is 1, just like the derivative of x is 1. So I just get e to the u times that little negative 1/2 that I took out. So it's negative 1/2 e to the u. That's my calculus. Now, put your x's back in. So that's negative 1/2 e to the negative x squared. So now that's your answer, that's your integration, and your boundaries are still from 1 to 0. So now you have to finish the problem with your boundaries. So when I plug in 1, I get negative 1/2 e. 1 squared is 1, so I have e to the negative 1. Minus what I get when I plug in 0. When I plug in 0 for an exponent, I get e to the 0 power. E to the 0 power is 1. So negative 1/2 times 1 is negative 1/2. So e to the negative 1 is 1 over e. So here's what it looks like I have. I tell you what I'm going to do is factor out a negative 1/2 since they both have it. And that's going to give me 1 over e, because I have e to the negative 1, which is 1 over e, minus 1, because I'm dividing out that negative 1/2. I'm going to leave it like that. The book might get a common denominator here or get all funky, I don't know. Or maybe from here, maybe you just want to leave it like that, negative 1/2, although you would need to put the e on the bottom, I think. Plus 1/2, that would be fine, because you have those two negatives there. So this is a fine answer. What I have written is a perfectly fine answer. If you're trying to check your answers in the back of the book might have gotten an e for a common denominator within the parentheses, and if that's the case, you would have 1 minus e over e. All those are the same thing, they're all fine, and that would be the answer to number 39. Alright, you know what? I stopped this video, but I started it again because I went to the back of the book because I was curious which one of these circled answers they had, and they actually had none of them, because what they did is they did not factor out that 2 in the beginning. So I want to make sure that you recognize, when you have what's in the back of the book and when you don't. So if we take this last one right here that I did and multiply the negative 1/2 back in, okay, you would get negative 1 plus e over 2e, right? Negative 1. So if I just do the 2 times the e on the bottom and then distribute the negative 1 on top, that's how I get negative 1 plus e. And then the book reversed the order on those two and got e minus 1 over 2e. So this is what the book had. Again, it's the same thing as this, which is the same thing as this, which is the same thing as this, which is the same thing as this. So sometimes when you're checking your answers in the back of the book, it may be in a different format than yours. Your job then becomes, can I take what I have, like I just did right here, and maybe distribute something or factor something and get what they got in the back. So don't give up just because the answer in the back looks different. It might be the same correct answer you have, just in a different format.